Okay, good evening, everyone. My name is Himanshu Patel, and I'm co-host for this group, Kubernetes and Cloud Night in North Dallas. So our main host, Damien, is traveling. That's the reason I'm covering today. Normally, I'm here, but been missing last a couple of events. We do this event monthly, and that's typically, I think, third Thursday of every month. We used to have pretty large audience before pandemic. Pandemic has changed quite a lot, so a lot of people actually listen to our event online. We do have a live streaming as well. So I just wanted to cover a couple of things before I introduce our speaker for today, and then we'll just get started. So we're always looking for good talking, talking points, and if you have any challenges or problems that you're working at your current employer or business, and you want to share with everyone, feel free to actually reach out to Damien or me. We're actually on our meetup page. You can actually reach out to us there, or you can let me know right after this event as well, right? So we're always looking out for good topics to cover in this event. Normally, this event is two session format. So we typically have two speakers every event. Today we have just the one. So second part will try to actually make it a bit interactive and see if anyone really want to cover something or talk about some interesting projects or challenges they're working on, or if there is any questions in the audience, and anyone of us or anyone in the audience can basically answer, right? So that's what we'll do today. We'll get started with this. I would introduce Terry. Terry has about 8 years experience. He's full stack developer, been on this event all the time. So he's going to actually cover some Kubernetes basics today. And without any further delay, I would just hand it over to Terry. Thank you so much, Terry. Go on.
Hi, thank you. So I appreciate you guys coming here to see me talking, rambling today. So my name is Terry. I'm just coming from the developer side, and then slide from the front end all the way to the back end, the database, and then once you move into a database, you got to deal with the DevOps stuff and network admin stuff a little bit. So I have always worked in a small companies, and it's always kind of like, hey, either you do it or you're going to wait years. So I end up, start doing DevOps stuff. So not coming from a well-trained background, but so I just go straight to the points. So I don't like to go over a bunch of fancy terms, because Kubernetes have a lot of terms, and it's really hard for a new person to get their heads around Kubernetes, because they have so many terms, and it really easily overwhelm them. So I like to use an analogy. So my analogy is just going to use a store, and the reason think of it as a store is, you go to a store, you buy stuff, and then you get out, right? It's very similar in a way that you go into a website, you get some information, and then you get out, So I just going to, get everybody in the same line to think of it as a store analogy. So a lot of these fancy words, hopefully you will later on find out why you want to use Kubernetes, right? So let's go over, the beginning, the really basic form of store, right? So you have a mom and pop old store over here, and so everything has a trade-off. There's no solution. I only believe in there's no solution. There's only trade-off. So with this setup, honestly, the Pro is super easy to set up, right? You just get a machine, get an old laptop, install some servers and get running, right? So, well, obviously, there's a problem with that, right? So you cannot scale. That's probably the biggest problem. So if you have too much customer visit your website, boom, it's going to blow. So it's going to crash, and it's going to be hard for you to recover from it. It's going to be monolithic because you only have one store, right? So all your business logic have to be in that service. So uh, and you guys know the real world business logic can be really complicated and they can constantly change. So it's not a great solution. Also, maintenance. We got to do maintenance, right? There's a lot of network admin stuff that hopefully you guys doesn't have to do, but like a certificate renew, just some example, or like a logging and stuff like that. They, upgrade database, they require restart, right? So when your database is upgrading, guess what? Your website is down, right? So obviously that is not a great solution for majority of the business. So for the longest time, this is the pattern that we use, like strip mall, so a multi-service architecture. So think of all the strip mall, the stores that like in a line. So you have like a big corner drugstore, right? CVS and stuff. Think of that as your UI page, your front end page have a lot of traffic, right? So they take up a lot of resource, a lot of room, a lot of CPU, a lot of RAM, a lot of network traffic and high IO, right? That can be your database, that can be your web's UI service. So they took half a quarter of your strip mall space, right? So in this analogy, your space, your space will be the resource, So what you do is usually you buy one or more really expensive box back in the day, and you install some hypervisor or VM software, and they spin up multiple VM, and you have maybe one gigantic one take like 80% of their CPU and RAM, and the rest of them give it to the smaller microservice. So, and you route it by, oftentimes route it by DNS, A lot of time back in the day, people just having multiple DNS record. So you spin up two instance web service, and you have a true DNS record, a record inside the LDAP DNS or Windows DNS. And if one go down or something happened, guess what? Oftentimes they will just change the IP of the old one, like let's say 19.10.1.1, and then the other one is 19.10.1.2. If the .2 went out because they got hardware failure, guess what? They're probably just going to either delete that record or just override that one 1.1.2 to 1.1. So there is definitely pros and cons with this architecture, right? So pros is now you can decouple your business logic, which is really important, and you can support more traffic in theory, right? But they have a limitation as far as this design is that the store doesn't aware of each other. What I mean is that let's say your customer go into a drugstore, but besides they getting the drugs that they need, they also are hungry. They got go to get a sandwich, right? And you got a subway right beside it. So you would tell your customer, hey, go over there to get your sandwich. But guess what? If the sandwich subway store already have like 100 people in there, they might already overwhelm. So your customer be waiting for a line forever, or they get angry and they left, and you wouldn't even know the customer left, or you wouldn't even know Subway is having a problem in there. So so that's where I mean by the cons is the store doesn't aware of each other. Each store have its limitation. So like I say, if your Subway is your small microservice all of a sudden for some reason getting super busy, it's really hard for you to scale it because you could open up another Subway, but it's going to take times. Even the fast DevOps back in the day, they probably can spin up within 1 hour. So you're talking about hours as a unit on response time. And it need public IP address, or it need more IP address, essentially, because if they are open to the public, every one of these servers needs its own IP address. And you guys should know that dealing with IP and stuff is a nightmare. When I saying each store needs its magnets, for example, it will be logging, right? Grafana, Prometheus, these like fancy logging solution, or certificate management that we mentioned earlier, right? These are the magnets. Now, because they are all in their own OS, they need their own, setup. Or you just have to set up somehow. It's going to be a mess. And there's no monitoring across the whole strip mall. So like I say, all these cons can have hack around to solve it, but it's going to be hack around. So it's not going to be like a built-in. So this is why we're going to bring up Kubernetes today, right? Kubernetes is kind of like a shopping mall, right? You have multiple stores inside of the shopping mall. And if one store goes down, you could spin up another lot in the you can find another place in the shopping mall and spin up another store selling exactly the same Subway sandwich, right? The customer doesn't care about is it from store A or store B. They just want the sandwich. So like I say, Kubernetes is in a lot of ways, it's kind of like similar to shopping mall. So shopping mall, you could have you have these resource, CPU, RAM, just like shopping mall have real estate, right? But within the shopping mall, you are free to allocate, to assign it to different store. So let's say if you have a lot more customer wants a sandwich, you can spin up multiple Subway restaurant. If you have multiple people want to buy electronic, you can spin up multiple Best Buy within the shopping mall. So that's the advantage of using Kubernetes. You use a fewer public IP. So I think each cluster, you don't even need the public IP address, but Kubernetes cluster is definitely going to, because the traffic route within the Kubernetes cluster itself, so they all use internal IP address. So you only need one public IP address to route all this traffic to support multiple domain. So that's the pro of it. Store aware of each other. Sorry, I didn't go in the order. Store aware of each other. So Kubernetes have a mechanism to like internal proxy server and stuff that saying, oh, if this service is this container or this pod went down for some reason, they will automatically try to restart one, So that's what I mean, like store aware of each other. And you can dynamically adjust based off like CPU load, or other resource, or use your custom script. And small magnets. So these are advanced topics that I don't really want to go too much into detail, but there's something called, for example, is something called Cert Manager that will automatically renew your certificate within Kubernetes. So guess what? Network admin loves it because, back in the day, each own service have their own certificate, and they all renew in different time. And guess what? If your network admin was on vacation and they forgot to renew it, your website is going to go down. So that's just one of many things that Kubernetes have a plug into. Also, logging, monitoring, these kind of stuff can consolidate into daemon sets. And that's more advanced topic, but I just couple example. So these are the pros of Kubernetes, but like everything, it's have its trade-off. So Kubernetes is really it's quite a lot of work to set up. There's going to have a lot of terms that is going to throw in your way, and manage it is really painful. It have like there's certain business need, but you could do it in the container level, you could do it in the pod level, you can do it in the service level. There's a lot of option available, which it could be a bad thing potentially. Security. Security is a big concern because now you have all the the service is all independent in their own OS, right? Now they are all inside one mall. So if one service or one application get compromised and somehow the user get administration access, now they can go around and mess with other stores. You have a solution to patch that, but in most time the basic setup, you guys just going to have one namespace or a couple namespace. But I just saying, there's more work to set up. There's a way to mitigate that, but it's just more work, and it's going to be hard to debug. That is my biggest complaint for sure, because when something doesn't work, most likely is related to networking. You really don't know, because like half the stuff is Kubernetes black magic. And most of the time, like 80% of Kubernetes issue is network related. And when things go wrong, it's like, you better have a really good understanding of like Kubernetes and like how all the components work in order to debug it. So yeah, so that is the way I kind of roughly explain, like think about how the compute history, deployment history in the past, and why the Kubernetes exists, So that's how I think about it, we didn't go into any technical detail, so here is come into the a lot of these buzzwords or whatnot. So Kubernetes have a lot of like resource. They call it resource, and I'm going to list some of the common ones in here. In here you can, I don't like, let me see. Okay, sorry, it's going to be a little bit smaller, but in here, in this picture, you have this green area is a pod, and pod is the smallest Kubernetes management level. Inside pod, you can have container, but as far as Kubernetes, the smallest unit they can organize is deploy is a pod. And service in here is in the blue area. And I think of a service as a door or mapping to tell, it's kind of like a door or map of the mall. It's a way to tell Kubernetes. If you think of Kubernetes as a shopping mall, service is organization mechanism to tell how to find the store, if that makes sense. So a couple of things I kind of want to point out in here is So servers have three different types of service. You have cluster IP, which is by default. That is, you can tell cluster IP is each of these store have a cluster IP. Cluster IP could point to one or more pods, and cluster IP doesn't expose to the public. They only, if you can tell in the picture, it only connect to the hallway, right? If you think of this green part is the hallway, right? So cluster IP doesn't expose the pod to the public IP. It's just kind of like internal door. Kind of like if you think about, think of it as a mall, cluster IP is like the shops or stores inside the mall, the doors inside the mall. And you have this no port service. No port service is, I don't think it ever used in production. It's more for debugging for developer to debugging. So think of it as a maintenance alleyway to the mall, and only developer use it. I don't think it ever used in production, but that's the way I think of it. Most likely, you're never going to route public traffic to the no port. Then in the service, the third type of service is load balancer over here. And load balancer, you think of it as the main door, the main entry for the mall. For example, like if we go to North Park, you will see North Park have these like gigantic main entry for you to go to the hallway. But also for this corner store that have a lot of traffic, they need their own entry. So the load balancer is the entry point from public traffic to go into Kubernetes cluster. So, and the reason, the pot, if you can tell, the pot is green, and then you have a pot, like a typical pot, like a service that you can imagine, like a WordPress or a database or microservice, right? Those are the green pots in there. But you can also have these like light green load balancer pot. Like I say, load balancer is a pot too. Think about the hallway in the mall. The hallway itself needs to exist inside the mall, and it take up space, right? Because it needs the capacity to hold the people, right? Just like that. I don't know how familiar you guys with reverse load balancing. Like a typical one, that very common one that industry uses is Nginx, and it holds what it does is hold all this traffic and route it to the individual pod. And it actually took up a lot of CPU and RAM too. So it's really a resource intensive item. Which brings me why each app don't have their own load balancer. This is exactly the reason why. Because you don't want a shopping mall, like you don't want a bathtub and beyond have their own door to the public, right? In the shopping mall, right? You only see like Macy's, you only see Best Buy. They have the public access to the parking lot, right? Because those doors are expensive. They take up space. They are expensive to build. Just like that, load balancer is an expensive item. So that's that's the reason why we have an ingress service. ingress service and ingress controller, think of it as a shared load balancer. So this is where a lot of confusion happened. And be honest, I probably did not explain it the best way I can, but like load balancer itself is honestly a bigger topic. But think of it, load balancer is the hallway, and so you, for example, like a smaller app, you wouldn't want to have their own load balancer, so you're going to use a shared load balancer. But for a big traffic app, for example, web UI, web portal, or API, you might consider to create a load balancer for those apps. So
Can you say that for when all the clients are coming, majority of the clients, that would be the UI, the load balancer? But it is a service like, somebody is delivering something, right? So the delivery services don't need to come to the front door, they come from the side door. They could use either Ingress service or node port service.
yeah. So they're going to have most of the smaller job, they're going to have a ingress rule. If you see the yellow part in here, you're going to, in order to find it in the public, you always have to in order to for each pod communicate with another pod, you always have to define a cluster IP. So regardless of your service is going to expose to public or not, but if your service need to communicate out within the Kubernetes cluster, you need to create a cluster IP. So cluster IP, you're almost guaranteed you always have to define that. But if your deployment is small and with small traffic, or then you can define an ingress rule. And what the ingress rule will do is telling them connect to the mall, the hallway itself. The hallway is the shared load balancer. And now you don't take up as much resource as a whole load balancer for, you are getting a seat. You are taking up a small portion of the resource instead of create a whole gigantic container and a lot of CPU and RAM. So for most of the smaller traffic, for most of the time, be honest with you, for most of the time, you're going to create a cluster IP, and you always have to create ingress rule, and that should be sufficient for you. 80% of the time, 90% of the time.
And if you have more traffic, then you go for the more traffic.
Yeah, then you get to create your own load balancer.
And whether the node port service.
Node port service is for developer. So most of the time you wouldn't use it in production. I don't think I ever see it used in production, but in some edge scenario, I'm sure it could use in production, but like most of the time you don't use it.
Yeah, I've seen it a couple of times.
Yeah, for sure. Like I say, I'm like I'm not going to be, I just stereotyping for.
And there are some limitations for the services and the ingress. Like Ingress usually is just HTTP. So if you want to expose something that's not HTTP, probably need to go like.
Oh yes, yeah, you are right. If you are ingress is just like HTTP, HTTPS. So if you are not going to use HTTP protocol, you're going to need their own load balancer. Yeah, that was a good point. I forgot.
Excuse me, sir. I was expecting when you mentioned load balancer, I was expecting the need for an ingress controller. Where does that fall in your?
So ingress controller itself is a load balancer.
Yeah. So you're using load balancer as an ingress controller.
Yeah, the ingress controller itself is a load balancer. Yeah, A lot of people didn't realize that. But yeah, like I said, ingress controller is a load balancer. Look at it in the diagram. It is both the same color, right? Right. They are a load balancer. That's where that's why the terminology can get really confusing. That's why I don't want to go in like these terms, because now you're going to overwhelm people. But I think everybody kind of roughly get it. So here is analogy.
Was there any other question?
Oh yeah, Danny. So here's the analogy. I love analogy. So sorry guys. So I love to think of it as like a cluster shopping mall, and each node is as a building. So a shopping mall could have connect by multiple buildings, right? And pod is a store. It could be a store. It could be a security office. Just some room inside the shopping mall, right? And a deployment is a chain store. So, just for the record, these are in the GitHub repo. You don't have to. You are welcome to, like, there's a link right there. So you guys don't have to write down and stuff. So a deployment is like a chain store. So you can deploy deployment saying, I want a 5 subway station store inside my shopping mall, and for some reason there's one shut down. Kubernetes will check it in some integral, and we're like, oh wait, there's only 4 subway store in there. So let me start another one up. So this is one of the things why you will use Kubernetes. A lot of people love that. Endpoint, I didn't mention this before, but endpoint is a term, but think of it as a store address or store number inside the mall. These will be a unique. Endpoint is an IP address, and it will be unique per pod. And yeah, that's probably what you want to know. You will hear them, but you usually not going to directly manipulate them. Daemon set. This is where.
I really want to know what this is.
So what I mean is every building have to need something. It probably shouldn't put bathroom. It should be putting a better example would be better analogy would be information center. Like each the building have to have their information center. The reason I pick information center is this will be a key item to for the Kubernetes internal working system. There is something later on you will tell. Oh, right here, kubeproxy. Kubeproxy over there on the left. When you go to a mall, don't think of the woman walk into the mall. Think of the man going to the mall. They want to go in and go out. The fastest way they do is they go straight to the information center, look up where the store is, and go straight to the store. In this analogy, is each building have their own information center, information desk in there. And when requests come in, they will be like, I'm looking for XYZ microservice. They will ask kubeproxy. kubeproxy will answer it and send them to the way, give them an endpoint, and then they will go to, go to that store, right? So daemon set is you only have one of those per building. And it's really similar to deployment, except that you only define one per building. So deployment could potentially have, let's say, for example, you have a shopping mall A and have 2 buildings, A and B. and I saying I want 5 subway, Kubernetes, there's a chance they have put all 5 subway inside of building A and no subway in building B. Daemon said what it does is they're going to say, I'm going to always put a subway in building A and always put a subway in building B. So the most likely it's used, for example, is Kubeproxy. Kubeproxy itself is a daemon set. Another thing that commonly used for is for logging. Like you have all these metric, right? Grafana dashboard, whatever, and you, instead of each of the deployment have their own Grafana instance and Grafana dashboard, you can all dump into one instance per building. So this is where I'm talking about the shared maintenance stuff.
And so for demon set, because I'm still learning about this, like you guys probably know way more than I do, but so is demon set that something happening like in the background? Is that something why you're saying like, okay, it's like the building bathroom? Like I just see no one says like I'm about to go to the mall and use the restroom, right? But you go to the mall and you're doing other things, but obviously you might end up.
No, I really put a bad note in here. It really shouldn't be build a bathroom, but like it's more like building requirement, like you know, like a building company will require you, like a city will require you, every building have their own, have their own fire station, have their own bathroom.
Forget the analogy.
Yeah.
Go with the demon set. What is it?
Yeah,
the
what
analogy.
is that?
Yeah, go with
Talk about what you said. So maybe I can probably answer that. So so if you look at the distributed systems or the world of Kubernetes, right? You have multiple applications running within the same clusters. Doesn't matter what they are. Some databases, some NoSQL, some applications, right? Applications, but like deployed with different technologies, right? But all of them might actually have some cross-cutting needs, right? They all actually spit out logs. You really want to flag those logs, and you want to actually ship somewhere like what Terry mentioned, right? Grafana or else or any other log aggregation tool. So that particular log aggregator, if you actually put alongside every single pod running in a cluster, it's just too much of a cost, right? It's going to actually utilize a lot of resources which could otherwise be used for your applications runtime, right? So that's the reason what normally happens is things like that which are cross-cutting, required across the cluster, basically deployed at the human side. So they're kind of background processes, and they keep running on the cluster, and they are exposed to all the logs, right? So whenever they basically ship the logs, they basically collect it, and so that's just one example. Many others.
Is it a shared? So can we think of it as? Can I think of it as a shared service? Like a common service.
You can.
And then the
It is
reports.
shared node. So, but
Shared
it is-
node.
yeah, so the cluster has multiple nodes, like multiple servers, payment sets will be replicated on each node. So for example, as logging,
And each one can have several pods, and the pod is the.
can have multiple pods, but it runs on each and every node. So if you want to pull logs, you want this to be shared across all the pods in the node.
Yeah, I agree. I mean, I mentioned cluster, but that's right. It's node, right? And one node can actually have multiple pods. So good direction.
Yeah, like I say, analogy only goes so far, and if you go too far, it's going to break. Honestly, that was a bathroom. It's really distractive example anyway. So
No, it made me excited because I was like really curious.
It's a cross-cutting need. I mean,
yeah, exactly. Like I feel like.
generally it does.
So it is shared.
Yeah, and you
Right.
have each and every building, which is
Right,
a
it's
node, so
required.
it's not
Right.
that bad.
Yeah.
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 We just have to flush it out.
Yeah. Yeah. So yeah, like I say, analogy only goes so far. But I do think now a shopping analogy will go really far as far as Kubernetes, because for a new beginner, there's a lot of stuff to go over, and like if I keep throwing you all these terms, without like a connecting mechanism,
Right.
then it's really overwhelming. So, there's other key components we can talk about over here in the picture. This is actually from Kubernetes official website. There's an API service. That's the mall manager. So earlier in this particular view, this is a user perspective, right? This is, in the view of, from the perspective of from the user in traffic, right? But for you as a network admin or a main developer that designed the architect this mall, that you as an owner, and there's a API service, which is the main thing that you interact with. You can think of it as a mall manager, and they have their own assistant. They have their own bookkeeping mechanism, and each of the nodes is a building, and each building have their own manager, and they have their own information center. And they also need something called external load balancer. This is actually live outside of Kubernetes. That is, for most of you, you guys won't deploy on premise anyway. So you guys going to Google, Amazon, they will make it so easy for you. Literally, like one extra property, and then boom, there you go. They will automatically spin up an external load balancer. But and you don't even have to worry about it, where it come from and stuff. But for on-premise deployment, you need to set up an external load balancer, which is pain in the ass. I'm just going to say that. Wow, what is the time? Oh my gosh, it's already 42. So I don't think we're going to go. Yeah, so there's some stuff that is open for event stuff. I'm sure there's plenty of people who knows all the stuff that I mentioned about. So like I say, security, how can I enforce advanced security control, network control? Those potential solution is obviously namespace. That's 101, and then you have a network policy that is slightly advanced, and then you have a service mesh that is going to be, huh?
That is highly advanced.
Yeah, I feel it's pretty advanced, but service mesh give you a lot of these black box matrix. So they they come with governor and Prometheus. So I mean, it's definitely really painful to. It's a hard work. It's a little bit work to set them up, let's say. But once it's set up, they give you a fancier dashboard and to impress your boss. But in reality, I don't find it super particularly useful. Until, like I am a developer, so for me, looking at log is the best way to debug. These IO matrix and these so-called black box matrix is not that useful. But
They provide tracing too.
yeah. Well, yeah. Yes, that's true. You could do tracing, but like most of the time, it's black box matrix for implemented in there. Tracing actually is considered logging, so that is not part of. Yeah, but like I say, there's many ways to implement these things. But these are the advanced subject we probably not going to get over in, and how to split the client. This is where analogy really break down. But like think of it as like implementing like a store back alley, because right now the store talk to another store. They are using the same hallway that the customer use. What if you really don't want that? You want customer use the hallway, and then you have internal service hallway, right? So that's where I mean back alley. You can do that in service mesh for sure. Plan shutdown building maintenance. This is really this is definitely advanced stuff. Monitoring the traffic inside the mall. That's one of the main reasons people use Kubernetes, because it's actually really easy to do that, relatively speaking. And deploy new store. So what I mean is really is the technical word is canary deployment and or blue-green deployment. These are really advanced features that you can roughly. It's not going to be easy, but it's relatively easier to implement inside Kubernetes. And store maintenance, like I say earlier, there's you could have multiple store share the same resource, kind of like food court. So what I mean is like a volume in here and auto scale. This is like HPA. There's a budget constraint that you could implement on top of that. There's definitely some complaint about here. Honestly, I really haven't. I've been busy, so none of these are really well written. But external load balancer is how to set up. I mentioned that before. Multiple region. This is way too advanced. But like security, like I mentioned multiple times. And there's some resource that cannot roll back. Secrets, config map, and
What do you mean cannot roll back?
you cannot roll back secret, right? Like deployment, you can roll back deployment, but you cannot roll back secret. I mean, it potentially have a solution. Like I say,
No,
like
I just didn't understand. I'm not speaking how it's said. I just didn't understand it.
so deployment, deployment have a
Yeah,
rollback.
we can roll back deployments.
But if you update a secret, there's no command to saying secret rollback.
Okay. So if you update the secret, how take effect into the.
Yeah, I actually did that before. I accidentally update the secret.
You need to kill the pods.
Huh?
To get updated.
Yeah, well,
You update the rollback and you have to bring it back original
but
value.
I don't have the previous value.
I agree to the second, so I
Exactly.
didn't get it
Yeah.
completely.
There's no rollback command as such.
Can you explain load balancer what the challenge is there?
Load balancer challenge?
Yeah.
Oh my. I honestly, my experience with load balancer is not that much. So like, I think we like pretty much have just one load balancer specifically applied to one of the web UI that have a lot of traffic, and then everything microservice dump into the hallway, the ingress controller. So yeah.
So it's hard because you need, if you're running on-prem, so you need to have a physical load balancer or someone from the network need to create a virtual load balancer. So you need some kind of manual work or make them available before you. Right. But if you're in a cloud anyway. Yeah, if you're in cloud, it's much easier. But that's not using a cloud provider, but using their own load balancer in the cloud. Yeah. Right. And that shouldn't be a challenge. It's just like if you're building an application, a load balancer should not be a big thing for you to add. If you don't want to use the providers, because everything comes with a cost. Yeah. So if you don't want to use the cloud provider load balancers, and you want to use your own, I think that would be more complex. That's why you listed it. That's why what is that complex?
Yeah. I mean, the trade-off is that you would be able to customize it a little bit.
Right.
But, yeah, it would be.
But I'm still trying to, what
This
is the
is,
challenge?
yeah, but this is like a load balance service within the Kubernetes cluster, right? But it's not outside of that. So the load balancing.
It is outside.
He's talking about
The
external.
service that's coming into, showing it.
Like so something load balance like a Cloudflare, it's load
Yeah.
balance from there
Right.
to the cluster.
Yes. The reason I'm saying is, yes, I like the cloud, I like Kubernetes, but what I'm challenged with doing the cloud provider services. The whole idea of cloud and open source, right? If I'm going to AWS and say, I'm going to use Kubernetes, but I'm going to use all your app ID, your load balancer and all those things, no longer open source, I'm still stuck with this. Right, so if I have an option that a third-party vendor is doing that. Yeah, you can do that. Like you mentioned, CloudSide can be used. Right, so that's why I'm saying, what is the challenge? I think he means here, tell you speak specifically about the on-prem solution, which is difficult to, you need to implement a physical one. But if you go to a service provider, doesn't have to be a cloud layer or anything like that.
So you just get the virtual machine from the cloud provider.
Yeah.
The cloud provider.
Yeah, well,
It's easy, that was, if I'm using VMware in the cloud, should I be, or should I not be? What are the chances?
Well, you just said you have to go through all that process, but with the cloud provider, or you spin a cluster, and the provider spins a load balancer for you. You don't even have to think about it. You see the difference?
Yeah, I see the difference, but I've also seen problems when
it's
there's
basically
I upgrade something,
Yeah.
I upgrade something, they don't do that and it breaks.
I guess it's not a challenge, it's just, you don't have to think about load balancer with the provider.
Yeah.
Are you planning to manage your own load balancer?
I know. Why would you want to
If you
manage
want
it?
to route traffic to your on-prem and you want to do some kind of like, you want to start traffic that's coming in and out of the.
Well, what if I want to use a multi-cloud? And hybrid.
If you want to do one, multiple cloud, you still can use the load balancer for each cloud. So if you want to run different clusters on different providers, right? So each cluster will have its own external load balancer.
So why would I do that? Why can't I do that with a single? That can span across.
I use global load balancer, right?
But that would have to be before it gets to be either provider or either cluster, right?
Yes.
So it would have to be external, so it would have to be,
Right.
yeah.
It's still in the cloud.
Mhm.
Because the-
But it has, yeah, so it's outside of the completely outside of the cluster, yeah.
I can tell you, send
Okay.
it to AWS, then it's on IBM. I can do whatever I want, that's what I want. I don't want to be limited by a provider.
But then you'd be limited by a load balancing provider.
No, but if I have,
So you'd spin up a cluster that is your load balancer, that you would then from which monitor all your other.
exactly.
Yeah.
GLP,
I think it's recreating a service that's already out, but I see your point about being a different level of control.
Because the load balancer is coming from all my clients coming in. Now, if I have a multi-cloud or hybrid, I'm tying that external source to one particular vendor. And the reason I want to be in the cloud is because I don't want to have multiple.
No, even if you want to use the multi-cloud, are you trying to provide the same service to client across the multi-cloud?
Yeah.
So you want to do that. Global.
I mean, it's some why everybody needs it.
That's an expensive solution.
So why? Load balance,
Yeah.
Because
Order to get
the middle,
I think those load balancers are out.
the middle layer,
Yeah, the middle there.
Yeah.
Yeah. So what is to do is get that and get into the route traffic.
I think you want to go to
And you
cloud
can-
first, right, but you're then tying yourself to cloud.
Right now, there, in the sector, I've got 3 different vendors. And there might be different geographical regions. If I'm working with a vendor, a client, and they use another client using the now I have to get into provide the service people. And I don't want to load balance this one and that. I'm covering all.
Yeah, so that load balancer can
Right,
balance
that's
between the
that
clouds.
sort of thing. And that, then the GLP.
No, but how do you reach the service within the cluster?
Yeah, I was gonna ask you, you already have this solution?
Something here. Something if you want to the cloud provider.
Yeah.
You still need those, the ones that I deleted.
Yeah. Yeah, you do have, you have to within that cloud, like within, if you spin up Azure, Kubernetes, you need to have an external load balancer within Azure in order to expose
This is
it
the one
to
that has
another
IP.
one.
Within here, within the Kubernetes, there is no IP, this is just internal IP. It's not exposed.
Well, I guess you could do a no port, I guess, if you really,
That's what I'm thinking.
yeah, but I just saying.
Like, the ways that Terry mentioned, to expose it, you need either no port, which is a bad practice, or a load balancer, which is this. And then you want to manage on different clouds, you can have GLB or global balancer that can, because these load balancers also, I just put this for simplification, but here, let's say on AWS, there are multiple nodes, node 1, node 2, node 3, and probably each one has a pod for your service.
This is good.
And these pods, each one has an IP internal, and you need to export them. So these three are exposed here. This load balancer can build that.
This is great.
So you still need this.
So and if node 2, for example, had another pod, then it would just be another line up to the load balancer?
I know. That depends on the application. Node 2, only speaking just one application. If you want to have another application and you want to expose it, probably you need to have another load balancer.
I think that's where you can use ingress rules.
Yeah, I don't think, you could use one load balancer. You don't have to. Oh, yeah, that's true.
I'm speaking generally, but if you want to go to specific HTTP, yes, you can have ingress controller, which is a load balancer, by the way. I got you.
So that's what I'm saying. So just like most of the web app or e-portal, right? Then instead of LB, you will have ingress services, and then they have a GLB that can be managed.
It's a load balancer then.
Yeah,
Alright.
Very good.
Yeah, but my question was going back and saying that, using this service, I'm using an application, the Kubernetes service, as opposed to a load balancer from AWS, right? That's what I'm saying.
No, Kubernetes service, which is, if it is a cluster IP, yes, you're within the cluster, it's just Kubernetes service. But if you want to expose it, it becomes an AWS load balancer, or it becomes a VMware load balancer, or whatever you call it. It becomes a physical load balancer, or a load balancer that's outside the cluster, not inside. Only cluster IP, like very much, is the one that's inside.
Yeah.
Yeah, well, this is where I think once you get into this niche subject, it's really confusing, honestly. Kubernetes, I hope the goal here is really set up like an overarching diagram on what is the terms and where it roughly lies. But the devils is on the detail, and these details are where most of the problem happen. I would say, I haven't set up these multi-hybrid cloud cluster solution before. So I have no experience coming to that point. So
You have any?
no, I'm done.
No, I think we're
What Terry mentioned is, think of the cluster as that big box. This is your cluster.
Oh, okay.
There is something called global chain. This is Kubernetes, like the CD and the database and all these things. So we both of that, like very ready, both of them. Just think of that this is Kubernetes. It's at the scheduling. Within that, you have multiple nodes or multiple servers, and the scheduler will whenever you deploy, so the scheduler will put the pod, put something here and here, and maybe put another application here. You mentioned in the deployment that you just need to replicate, so we will do that. So you can communicate between the nodes and between themselves without an issue, or without an issue. Actually, there is a cluster IP. This is how they communicate together, the pods. And this is why you mentioned on the service, you don't need a real load balancer. Yes, you don't need something. It's just running within the cluster. But if you want to expose it outside, this is where you need a load balancer, and it will expose the internal IPs to the outside world with the export. So this is how they communicate. The node port will be a port that's open on the node itself, and it will be the same port on both nodes. When you expose something as a node port, so let's say this is a database, this is maybe Postgres, so nice Line 456.
I don't remember. Oh, 5324, 532, 5532.
559, 439. It should be here. And then we all on the cluster on a different port, but this is how we should go. And then every node port you create, it will create all the nodes with different, with the same port. And that's why it's not the good practice. So you're opening a node to the, a port to the node itself, and it will be added and added, and you can just keep opening more ports on the node, which is security issue problem.
I know certain database will use that as a feature, like certain distribute database, and you want to like, I want to make sure that record is only in certain, like, you know, like Elasticsearch, right? You have multiple shards, and like you want to like, oh, I want this record always in like this particular, then you use no port. But like I say, this is like really rare, like edge use case.
For example, something that always involves an also. Creating a new, you have another things that this could be like logging, pulling logs from the node. So it's not on the node itself. It checks the traffic on the node. Maybe something for security checking. So maybe you run the physical node. Yeah, that's it. And this scheduler keeps checking how the capacity of all of these nodes, how many pods should I schedule here or schedule here. This is a decision for the scheduler.
Is there any communication between the daemons?
That's a good question. If there is, it will be through cluster ID.
If it is, what will be the reason?
That depends on the application itself.
Yeah.
Depends. Maybe they are thinking, some of them they just heartbeats, just make sure that because
Oh, okay.
maybe they're doing something that they haven't been, I don't know, but there are multiple use cases.
Quick question. So your load in your diagram, your load balancer right there, is that the line, the box you have denotes the cluster, right? And the load balancer is sitting outside of the cluster. So which one is this? Because we have three services, right? We have cluster IP, the load board, and the load balancer.
Yeah.
So the load balancer service.
So if you want to expose something within the cluster,
Yes.
that's a cluster IP. And if you want to expose something outside, that's the service type is load balancer.
Okay, so that service type sits outside.
Yeah. Service. Yeah, it's a load balancer, but the type of the service is load balancer.
Yeah.
And the node port is here. If you want to expose something.
Yeah, got it.
So these are the three different nodes. Ingress controllers are something that's running. It's a service that runs on the cluster. So it's an application running here, and probably it's running there as well. And it is a load balancer in a way that it can do load balancing, say, doing this and this. But it can also understand the URL. So let's say you go to example A, and this will go here to an IP. So the DNS will check this URL or this thing and translate it into an IP that will go to this load balancer, which is called an ingress controller. Ingress controller. And the ingress controller will reach here and understand, okay, example A, this is this application. If it's maybe something E, so it will reach the same ingress controller and it will understand, okay, example B, oh, that's this application.
But
So this is where you have just one load balancer, but it can handle multiple.
it seems like the way you have your architecture, you are communicating directly with the ports, i.e. with the nodes.
Sorry, my mistake. Should be through a cluster.
Actually, going through the problem.
It's through a cluster.
No, you don't want it to be busy in the bordering control plane.
Yeah.
Because
Nothing goes to the control plane at all.
control, you don't want, if you have so much traffic, then your control plane get like ignore the shutdown request or something, right? So the control plane is for control only.
Okay.
Not like a firewall, it's not like an ingress.
Control plane has just three main things. Which is defining player, document, log storage. Usually everything is implemented in one there. There are some okay. And then which is store just configuration, the database, the cluster, and has the API server. These are like the main three. I think there's more one that I forgot, but these are the main three. API server is how you communicate with QCDL or say API server, just APIs. So when you QCDL, create pods, it will go to the API server, make sure it's authenticated, and you the right one to do it, and then it will read from it.
There's a couple of things to point in here is that it's not intuitive, but Kubernetes authentication mechanism only support, like there's no user concept in Kubernetes. They only have like a certificate, right? Certificate. So you got to create like a certificate per user. So don't expect events you are off and off control inside Kubernetes. That need to be like Kubernetes is authentication control is really basic.
Yeah, I think I need to run outside of the gator or outside, and then they provide